November 16, 2025. Astrophotographer Satoru Murata quietly uploads a new composite image of the interstellar object 3I Atlas, and within minutes, the astronomy world practically stops breathing. He stitched it together from 24 one-minute exposures through a modest 0.2-meter telescope out in the silent deserts of New Mexico. Nothing about the setup hinted at what would follow, because the moment you look at the image, you feel something's wrong, or maybe too perfect. Atlas is spraying out multiple jets, each pointing in completely different directions relative to the sun. One of them is an anti-tail, another a razor-thin, impossibly straight plume stretching across distances so large they shouldn't maintain that geometry. These jets don't bend, don't twist, don't wobble. They look frozen mid-motion, like cosmic laser beams. And you're about to learn why that's become such a problem. Within the same week, 7 independent observatories checked the physics behind those jets, and their measurements flatly contradict what our eyes are telling us. That contradiction is so sharp that Harvard astrophysicist Avi Loeb stepped forward with 4 possible explanations, and 3 have already failed. Think about this. If Atlas spins 45 times in the month it takes gas to drift outward, then the jets should be smeared into spirals, not locked in one direction like arrows nailed to the sky. But then things get stranger. Just a day after Murata's release, astronomer Francois Kugel uploads his own follow-up. This time, 22 shorter exposures, using a much larger 0.4-meter telescope. And yet, he captures the same thing. The same straightness, the same defiance of rotational physics. Atlas spins once every 16 hours, and its jets stretch over 1 million kilometers, enough time for rotation to twist them into ribbons. But they don't twist, not even a little. And at this point, astronomers have ruled out every boring explanation. Not a camera glitch, not an artifact, not some perspective coincidence. Multiple nights, multiple observatories, multiple people, all seeing the same impossible geometry, which leads us right to the newly confirmed 12th anomaly of 3I Atlas. And this one may be the most unsettling yet, because it attacks the very physics that has guided rotational dynamics for 100 years. But before we dive into why anomaly number 12 is causing so much discomfort, you need the bigger picture. Give me 20 seconds and I'll show you how Atlas built a track record of strangeness so long that pure chance alone can no longer explain it. Start with its arrival. It entered our solar system on a retrograde path aligned within 5 degrees of the ecliptic. The odds? About 0.2%. That's like landing a dart on the edge of a dime from across the room, blindfolded. Then, during July, August, and early November of 2025, Atlas threw out a jet pointing toward the sun. Not a trick of perspective, material actually moving against radiation pressure, something comets simply do not do. Its nucleus is absurdly massive, 1 million times heavier than Oumuamua and 1,000 times heavier than Borisov. Yet somehow it's traveling faster than both. The probability of that combination? Below 0.1%.
At its timing, practically choreographed. It swept past Mars, Venus, and Jupiter at distances perfect for observation, while slipping past Earth at perihelion in a way that made it completely unobservable. The odds of hitting that exact sequence? About 0.005%. It's as if the cosmos dealt us a hand of cards no one should ever get. Spectroscopy only deepened the mystery. Atlas carries far more nickel than iron, a signature closer to engineered alloys than random cosmic debris. This thing is ancient, perhaps 7 billion years old, and 7 billion years is a very long time to collect, Well, junk. That might explain why its nickel levels blow the charts off the page. And it keeps going. Its nickel to cyanide ratio is thousands of times higher than any known comet, including Borisov, a less than 1% probability. Its gas plume, only 4% water. Comets normally come in at 80 or 90. And the icing on the cake? Its light shows extreme negative polarization, a trait not seen in any comet ever studied, even among interstellar visitors. Again, probability under 1%. And that's the backdrop. With all of that behind it, Atlas now has a 12th anomaly, one that challenges the very mechanics governing how objects rotate and shed material. And that's why astronomers around the world are, frankly, rattled. And then there's the part almost no one expected. 3I Atlas didn't just wander into our solar system from some random direction in deep space. It arrived from a patch of sky within 9 degrees of the famous 1977 WOW signal. Yes, that WOW signal. On August 15, 1977, a radio telescope at Ohio State University detected a sudden, powerful burst of radio energy that stunned the astronomer monitoring the printout. He circled the signal and wrote one word in the margin: wow. When Harvard's Avi Loeb checked Atlas's incoming trajectory, he realized something unsettling. It came from almost the exact same region of the sky. Not identical, but shockingly close. The probability? About 0.6%. Not impossible, but uncomfortably low. As it neared the sun, things only got stranger. Atlas brightened faster than any comet ever recorded and turned bluer than the sun itself, an unnatural shade for an icy remnant drifting between stars. Its jets, meanwhile, demanded surface areas far larger than the object actually has in order to absorb enough light to power such massive outflows. Then came the acceleration. Atlas wasn't just moving under gravity, it was being pushed by something. The calculations demand at least 13% of its mass evaporating to explain the non-gravitational acceleration. And yet, the object stayed completely intact. No cracks, no fragmentation, no breaking apart the way every comet experiencing that level of mass loss should. If an object keeps its shape while blasting out high-speed jets, you eventually have to consider the possibility no one wants to say out loud: a technological origin. By this point, Atlas had accumulated 11 independent anomalies, each improbable on its own, but together forming a profile that strains natural explanations past their limits. And that's the line professionals must draw, knowing when the data no longer supports the comfortable answer. The 12th anomaly crosses that line entirely. Between July and August 2025, 7 separate telescopes measured Atlas's rotation period. Their results were identical: 16.16 hours per rotation. These weren't one-off observations. They were repeated across weeks with the same outcome. No deviations, no uncertainties. This isn't preliminary data. This is solid observational fact. Meanwhile, earlier imagery from November 9th showed massive gas plumes rising millions of kilometers from its surface. Using the known outflow speed, Loeb calculated how long the gas would need to travel from the nucleus to the ends of those jets. About 1 month. Simple physics, nothing exotic. And it's this simple physics that creates the paradox giving Harvard astrophysicists headaches.
Here's the issue. If material takes a month to travel outward, while the nucleus rotates every 16.16 hours, then Atlas spins around 45 times as the gas is leaving the surface. That many rotations should smear the jets into spirals or fan-shaped structures. The nucleus would be turning under the outflow, constantly changing which vents face the sun. Every comet we've ever studied behaves this way. Think of a lighthouse. The beam shoots straight out, but because the lighthouse rotates, the light sweeps in an arc. Comets work the same way. Vents heat up when illuminated, Jets activate, then fade as the nucleus spins. The result is curved trails, branching jets, twisting ribbons, motion written across the sky by rotation. But Atlas isn't sweeping anything. Its jets remain fixed, laser straight, as if frozen in place, ignoring the spin entirely. But 3I Atlas doesn't behave like anything we've ever seen. Its jets aren't the chaotic, wind-swept plumes we expect from a spinning comet. Instead, they shoot into space like razor-thin beams, sharp, unwavering, and impossibly consistent. They stay locked in the same directions for nearly 1,000,000 kilometers, as though the object generating them never rotates at all. No spirals, no curves, no soft arcs carved by motion. Just frozen precision. And remember, as that gas travels outward, the nucleus is spinning, a lot. About 45 full rotations in the time it takes the material to reach those distant jet tips. By every rule of comet behavior known to science, those jets should smear into corkscrews or fan-like sprays. But Atlas refuses to play along. That's when Avi Loeb stepped in with 3 natural explanations, and one by one, they collapsed. The first idea was simple. Maybe Atlas slowed down. If its rotation rate dropped since July, the smearing would decrease. But outgassing increases spin through torque. It doesn't dampen it. And fresh images from November 11th show the nucleus untouched. No explosion, no breakup, no event that could suddenly slow it down. Strike 1. The second explanation was more creative. Maybe there are deep shaded trenches full of ice that only catch sunlight only once each rotation, firing jets in pulses every 16 hours. The problem, with a month-long travel time, those pulses should create a series of spaced beads along each jet, a string of brightness knots marking each burst. But the jets are smooth from base to tip, uninterrupted. Strike 2. The third option was fragmentation. Perhaps the jets aren't jets at all, but trails of debris from a shattered nucleus. Yet all data confirms Atlas is in one piece, not a single sign of a breakup.
Strike 3. And this is where normal comet physics throws up its hands. Because to keep those jets perfectly straight while spinning dozens of times, Atlas would need to compensate for each rotation with unbelievable accuracy. No natural thermal or geological process we know can do that. Comets wobble, they flare. Their jets flicker like campfire flames. But these jets? They behave like something responding to rotation and correcting for it. And that's when Loeb carefully introduced the fourth possibility. The one scientists discuss only after exhausting everything else. Spacecraft do this. They fire reaction control thrusters that hold their orientation steady, counteracting every twist and spin so their path stays true. Incredibly, the jets on 3I Atlas look eerily similar to the output of such engineered systems. Loeb didn't claim Atlas was technological, but he did say the behavior mirrors what attitude control thrusters would produce. Yet, even if we insist on a natural explanation, the only options left are things we've never observed in any comet. Strange internal structures that partially uncouple rotation, exotic materials behaving in unexpected ways, or ice formations that somehow emit gas in perfectly stable directions regardless of spin. But nature is messy. Nature doesn't engineer precision. Rotating bodies create chaos, not order. And that's why these laser-straight jets feel coordinated. While the mystery deepens, observatories around the globe have joined forces. Teams are reprocessing images, comparing jet brightness to rotation timing,
running spectroscopy on the gas, and even scanning for structured radio signals. Measurements so far show normal comet outflow speeds, meaning the month-long travel time still holds. And that leaves the contradiction intact. Jets that should twist, but don't. A spinning body that should paint curves, but somehow draws straight lines. 3I Atlas isn't just presenting anomalies, it's presenting a story. 12 chapters long, each one refusing to match the model we've relied on for generations. And this 12th chapter, the one that challenges angular momentum itself, is the most unsettling of all. When the universe hands you evidence that won't fit the box, eventually you have to consider the box might be wrong. And yet, in the midst of all this chaos and contradiction, 3I Atlas leaves us with one final clue: a line. A perfectly straight, impossibly steady line etched across the void by an object that refuses to obey its own spin. It's as if this interstellar visitor has taken a pen and drawn a deliberate stroke across the sky, challenging us to follow it. Physics has always been our compass, reliable, repeatable, relentlessly consistent. But every compass has a border, a place where the map ends and the unknown begins. Those laws work beautifully within the realm we've tested them. But what if Atlas is showing us where that realm stops? Maybe this object marks the threshold where long-trusted rules begin to stretch, or where entirely new rules begin to take over. Rules we've never witnessed in action until now.